Hi everyone and welcome to the Data Structures and Algorithms Mastery course, and I hope that you're doing well. And from this video we'll be actually starting with the data structures, which are very important or plays a very important role in software development. Okay, and in purpose of your interview point of view, or you want to learn more in computer programming and any kind of domain. So data structures are very important, so we'll be focusing more on data structures and algorithms. Okay, so in this video we'll talk about linked lists, as there are a lot of videos coming on linked lists, solving the problems and some conceptual videos and a lot more. But first of all, what you have to do, we have to understand actually what a linked list is, and we have to make our first linked list. Okay, so I had my board in front of me and this is my pen, and now I'm going to start teaching you. Okay, so what is a linked list? But before talking about, let's talk about arrays. So what are arrays? Can you just pause this video and comment in below what is arrays? Arrays aren't just arrays are also data structures, as you know, that we can store and data into the arrays, and the data should be the same data type. Okay, so some of the limitations, I'm going to point it out. There are a lot of limitations and there are a lot of advantages of arrays, but some of the limitations of arrays I'm going to list it down here. So the first limitation, I could say that we have to specify the length of an array before putting the data over there. So there's a problem because you have to specify the length. So in specifying the length, there is one problem arises, that maybe you need more data space or more memory region. It maybe you want more region. Some of the limitations of arrays is that specifying the length, so it leads to two problems. The first problem is you want more region in between, or a memory region, or you have left with if you have made a large array, then you have consumed a lot of memory region and you have only used a small point of memory region. So it is a shortage of memory, in short, I could say. Okay, so this is the first limitation I could think of. The second limitation I could think of, that the data will be stored will be of the same data type. Should be of the same data type. That is not perfect. Okay, so that's why we have our favorite linked list. So that's why we have to study more and more data structures. And linked list also, there is also various kind of advantages and disadvantages also. But arrays, linked lists, all this kind of stuff are very important in terms of software roles. Okay, and the one other thing that I could specify here, that the notes will, the description down box below, be sure to take a look at the notes, download the notes, and do the practice problems, and follow me on LinkedIn because I provide the practice questions over there. Okay, so what are linked lists? So let's say I will first talk about something out of, this is our memory region, I could say. I'm not going to tell something out of here. This is our memory region. Okay, so this is my memory region where all my data is stored. So let's say what linked list does, it's get the data and store anywhere into the memory region. So here we got 20. So here is stored 20, and then it got another data is stored here. He stored here 30. He got another data. He stored here. Whenever he finds the space, he stores the particular data. Okay, so when a linked list, what it does, so whenever it finds the space, it stores the data over there. Okay, so we have this kind of thing. Okay, so and this is what linked list does in storing the data. But you might think of a problem that how do we assess the elements? How do you have to assess the elements if our elements is long away from each other? So what the linked list does, with the data, storage of data, it stores the reference point of the next data. So it stores the reference point of the next data. So this is the next day data. This is an example, this is an example. So let's say, as an example, the address of this data, is 150. Okay, so it stores at the rate 150, means it is storing the address. So if we know the address, we know the data. Okay, so with the data, it stores the address of the next data. It happens in linked list. Okay, so if we know the address, we can find out the particular data. Okay, so it stores the address of this 50. And what 50 does, it stores the address of this data. So let's say this data is 160. So it stores the address of this. Okay, now you can see here that if this let's say A, B and C, so A is equals to B and B is equals to C, then it's obvious A is also equals to C. Okay, so you can just see here that we are forming the link. Now this will store the address of this data 40. So let's say this is 170, so this stores 170. The address of this data is 170. Now you will ask, and I will eventually ask, so it will storing this data. Now we'll eventually ask, hey Yush, what about this? To whom he will reference, or to whom he will store the data? I do not specify the gender. It says it's. So who in this, which reference point or which address will be stored here? As it's storing this address over here, and this address over here. Okay, so this is forming the link. But what happen there? When we reach out to the end of the linked list, the end node, we say the element of linked lists means in arrays you have an element like 4, you have 3, you have 2. So in the same way, in linked list, we specify this as a node, this is as a node, this is as a node. Okay, so we specify this as a node. Okay, so let me tell you, when we reach out to the last node, and the last node is often called tail. Okay, so in linked list, the last node in linked list is called the tail, and the first node in the linked list is called head. Okay, this is a two naming conventions that I can give it to you. And in tail, we usually represent as a pointer, means the reference point, I could say. This we are storing, another thing we are storing at the rate, this is called the reference point, or we can say pointer, whatever you want to say, but it's referencing to other node. Okay, so this is the reference point. So in tail, the reference point is null, because it does, just think about it, whom it will store the address. So it has nothing, so it will reach out to null, and that indicates that the linked list has end. So it is forming the link. So that's why this is called linked lists. So that's why this is called linked lists. Clear? Pretty much easy what I'm trying to say you here. Again, recapitulation. And the first node of the linked list is called head. The last node of the linked list is tail. And the last node, the reference point of the last node is null, as it's obvious that it doesn't have any kind of to reference the address. And it is forming the link, means the first node will store the address of the second node, and the second node will store the address of the third node, and the third node is equal to the first node. So it is equal. So it is forming the link. So what I could suggest here, that let's bit twist here. So if we don't know, if we don't do any of the link, if we don't store this, so this linked list will be very kind of bad, because of this linked list, because of this node, we are knowing the address of this. So we have to be very careful while giving the directions, or while giving the reference point over there. Okay, so I think that you got familiarity with this, and I hope that you had got about an overview of the linked list. Again, linked lists are the data structures that help us storing and retrieving the large amount of data quickly. Okay, so now we'll talk about some of the disadvantages. We'll talk about as we go further, but the main disadvantages is in here that it requires one extra space for storing the reference point. Okay, so this is the main disadvantages of linked lists. Okay, pretty much easy. The conclusion is given in the notes. Be sure to take a look at that. Now, in the fast way, what I will do, I'll code a simple linked list for you. Okay, so I'll go here, and I have already made a node with Java, means the class here. So what I will do, I will make two variables. So it will data. First, it will be our data, and the second will be our next. So again, I'm explaining you what I've done here. It's next. So what I've done here is that every node is something like this. You have this node, this is the node, and half for storing the data, this for storing the data, and this is the reference point. So it is we usually call this as a next. Okay, so next to the data. So that's why we denote it as a next in this course. Okay, now I will make an constructor. Maybe you know that I will make a constructor that will take a simple data, because we only want data from the input. We will take care of all about the reference point. Okay, so we'll take out the data. We'll take the data from the input. Okay, as it is constructor. Now this dot data, and you might think, hey Ayush, what is this? This indicates that we are using this data, this global variable. Okay, so we are using this data. Okay, so that's why we use this for denoting this. Okay, so and in the next we'll first of all, because we have a single node, and the next of the single node would be null, because we don't have any kind of data for storing the next node. We don't have any kind of address, because we have only have one node, and in that node we have a data and a null value. Okay, so we have the one node is here we will store the 10. Let's say this is the data, and here will be stored, because it doesn't have any more node, so it will restore null. But we'll see just in a second how we can remove this node. Okay, pretty much easy. Now we have made one thing, but one thing I could like to notice here, but now not. Okay, but now not. Let's go on to make a use of this. Okay, so I have made another kind of. So I'll just remove, because there's no need for. Okay, so what I will do, I'll make an object. Oops, I will make an object node 1 equals to new node, and it's take 10, because in scanner you can say in the scanner you have a system.in. So in this view we want data. You can see here that we want data. We are asking for data. Okay, pretty much easy. Now what I will do, I will print out the node1 dot data, because we want the data, and again I will also print out, I will take out a null value. Sorry, the next means the reference point of this node, of this object. So if I run this, so it will tell me first of all 10 and null, because we have a null in the reference point and we have a data into the data as indicated. Okay, now let's make another node. Node 2 equals to new node, and let's say 20. Let's say 20. Okay, so let's say 20, and then I will print out the next node. Out.println node 2 dot data. Okay, so it will print out 20. But what if we print a node 2? Node 2, it will give out the address of node 2. So what in linked list we do is that if you can see here that we have made one node 1. We have our node 1. We have node 1, and in node 1 we have stored date 10, and this is null. And we have again made node 2, and here 20, and this is null. So what I will do, I will make a link by removing this null with the address of this. Okay, so how do we get the address? The object, if you call this simply the object, this node 2, this will return out and our favorite. This is our reference point. Okay, where our node 2 object is located. So what I will do in node 1 next, I will remove this because it will confuse you. It will confuse you. So we have two nodes. So in node 1, I will store in node 1 dot next. I will store at the address of node 2. Okay. So if I print out the system.out.println, so node 1 dot next, it will not be null. Now it will be address of the second node. Pretty much easy what I'm trying to say you here. Okay, so pretty much easy what I'm trying to say you here. And now one last point that I could add, that I could notice here, that you might know generics. And in Java this is a generics. I don't know about the C++, I don't know about the Python, but in generics what we do, we only have the right to define, we have to define integer data type. We want a different data types. So we have to, for float, we have to make another class, for another constructor, for we have a string, we have to make another constructor, and all those kind of stuffs. So for avoiding that, we have a generics. All in Java, if you're in Java, as you know, this is T. We make the generics as a T, and we replace all, we want T, whatever it would be, and here I will put T, and now I will put T here. And don't be confused, this is generics. This is only for that we can use any kind of data type. We don't have to make more constructors over here. Okay, so now we have to provide here what kind of data we want to store. What kind of data we wanted to store. So in this case, we want to store integer. So we'll write integer. Pretty much easy what I'm trying to say here. Okay, so again, the notes will be in the description box below. Be sure to take a look at that. You will understand after this video. Just take a look at that and you will be understanding more and more. Okay, so it's already 7 minutes. So thank you for watching this video. I'll be catching you on the next video. Till then, subscribe to this YouTube channel, press the notification bell, and next video will printing out like this. So thank you for watching this video. I'll be catching you on the next video. Till then, bye bye.